All right. Hi, hello, and a very good morning, everyone. Welcome to webinar on data science, the new future. So I'm Miloshna, one of the APU ambassador of Brigit, and currently pursuing my final year degree in data analytics. So hope everyone is doing good and staying safe. So before we start, please note that you can put in your questions in the comments and during the session, and I'll try my best to take them note and deliver it during the Q&A session. Your cooperation throughout this webinar is highly appreciated. So can I get a thumbs up for that? All right, thank you so much. Without any further delays, let's get started. So today's webinar is going to be about data science and what's all about in today's world and in the future. For that, we could never expect someone better than Mr. Pradeepta Mishra, our honorable speaker of the day. It's a great pleasure for me to introduce with his defining experiences. He's the head of AI product engineering at LTI and leading a group of data scientists, computational linguistics experts, machine learning, and deep learning experts. He has filed 5 patents as inventor relating to application of data science, machine learning, NLP, and energy. He's also an author of 4 books in the same sectors and currently working on the 5th book on practical explainable AI with Python. The most amazing part is one of his books has been a textbook in University of Pittsburgh in USA. Even the latest book, PyTorch Recipe, is also added into the computer science course as a textbook in Virgin College in USA too. Despite being an important member in shaping the AI curriculum in 3 universities, as a speaker, he has delivered more than 250 plus talks on AI and data science at various firms. And today, he's with us. With that, I warmly welcome Mr. Pradeepta Mishra for today's session. The screen is all yours, sir.
Thank you. I hope you can hear me. Yes, okay, great, cool. So today we are going to talk about why data science is considered as the new feature and what are the solutions or what products we can create for the future and what is data science and what are the related terminologies that are being used today. So for example, machine learning, artificial intelligence, natural language processing, and we talk about deep learning, etc. So these are all associated and used synonymously along with data science. And why data science is typically the future is something which we are going to talk about in this series. So the beginning of data science, I can say in the year 2012 December, the particular word data science came into picture. And this is an outcome of an intense debate between three genius people in the United States. And they come up with a term that, okay, a new identity has to be given to data driven insights. Now, what is that new identity? The new identity is that you have to ask right questions, which means if you are running a business, if you are analyzing something, right questions. If you can ask right questions, you will get the right answer. As an example, if something is not working, something is breaking, why it is breaking, why it is not working, right? So simple examples you can take. Let's take a maybe a manufacturing sector. So what is the probability of the machine is going to fail, or how long this particular machine is going to run? If you want to make a prediction, right? And can I predict the lifeline of a particular machine? Can I predict the lifeline of a particular device? So if you don't know how to ask right questions, that's the beginning of your data science journey. So as a student or as a professional, first thing, you have been given a data set, you have to ask right questions. Okay. And of course, if every individual has their own opinions, has their own thoughts around something. But what is important is that without data, any thought, any hypothesis, it's not valid, it's not useful at all. So what is important is, if you have opinion, support it through data, support it through the help of data. That's why only the data driven decisions that is making sense in the real world scenario. Now, if you look at the population growth today in across the world, just look at the internet population growth and just compare. It's almost double, 3.4 million people global internet population, and in 2016, and 5 years down the line it is 5.2 million people, and 2020 as we are speaking it is reaching almost 5.8 million internet penetration globally, which gives us an insight about the volumes of data that is getting generated, which talks about the amount of data that is getting generated. What are those different kinds of data? Now, earlier we have seen data like tabular structured data, where you can see the rows and columns like in Excel, CSV, or something like sort of like that, which is very much structured. Now, what is important today is that you can see very huge amounts of unstructured data that is getting generated. So, for example, through WhatsApp, we are exchanging messages. Through WhatsApp, we are exchanging images. Through WhatsApp, we are exchanging audio clips. Now, this is also data. Now, this unstructured data is also getting stored somewhere, getting circulated. Now, there are certain data science procedures which you need to apply to get insights out of it. As an example, how many times a particular image is being circulated, how many times the video is being circulated, what is the viral ratio of a particular video, and how people are communicating, whether it is a cropped video or it's an original video, whether it is a cropped image. So anomaly detection on images, anomaly detection on videos. So these are a couple of use cases, or you can think about some scenarios where you could use data science to extract knowledge, or data science to extract insights from unstructured data as well. So that's why, what is data science? And because we have seen the volume of or you can say the number of internet users, they are increasing significantly year on year, and because of which it is producing huge amounts of data, and those data is like both structured and unstructured data. Now, as the data size increases, it becomes very difficult to take decisions, very difficult to take business decisions. Now, what it takes to understand, or what it takes to know or to get insights from taking the decisions. So what is data science? Now, data science is nothing but it's an interdisciplinary field that basically uses scientific methods, processes, algorithms, and various systems to extract the insights, to extract the knowledge from the data, both structured data as well as unstructured data. Now, sometimes the businesses they do have data, but they don't know how to extract insights from the data. They have tools, they have systems, but they don't know what to extract, what is meaningful, what is actionable. They don't know. Now, that is why the data science process, the concept of data science is to unify various business decisions, or as I said, various business processes through the use of statistics, data analysis, machine learning, deep learning. So these are various fields which can be combined together to get to extract insights from data. That's why it is very important to understand the data science processes at an overall level. Now, having said that, what is data science? So, as I said, the data science is an algorithmic intervention, or a mathematical, or you can say statistical computations on the data itself to extract insights. And this extraction of insights is always corresponding to the clearly defined business problems. Now, what's typically a business problem? Right? A business problem could be, you can think about any domain, like let's take sales and marketing, or let's take about banking or financial services or insurance for that matter, right? If I just talk about insurance industry, so what are the typical business processes? Business processes could be underwriting process, business processes could be claim processing, it could be deciding the premiums, it could be deciding the like the eligibility criteria for insurance. So there can be so many business problems. Now let's talk about only one problem, which is the claim processing problem. So typically, how do you apply for a claim? and how the claim is getting processed through the insurance company, and how the decision is being taken whether the claim to be paid or claim to be denied. So this entire process, if I just think about now, can data science be part of this? Yes, of course, because here the decisioning is there. Now, when somebody is applying for a claim, definitely the documents have been submitted and somebody has to verify the documents and just decide the legitimacy or the legality of particular claim, whether it should be paid or it should not be paid. Now, if it should be paid, it should be approved, right? So there is a decision making process involved. Now, in any businesses, if a decision making process involved, so the decision is being taken currently either by a human being or by a machine. If it is taken by a human being, there can be biases, prejudices, there can be like heuristics or past historical experiences, but it's not algorithmic driven decision. So if you want to like introduce the algorithmic intervention here, it would be bias free, it would be prejudice free, which means the algorithms have no like prior, or you can say prior experience, or maybe prior thoughts to take a decisions. They completely look at your data and take decisions, right? So this is an example from the insurance industry. Now let's talk about another industry. Let's take retail sector. In the retail sector, sometimes I'll talk about a problem which is called store space problem, which means we have seen the stores, the superstores where we go for shopping. So grocery items we go for shopping. Now sometimes what happens, there are shelf spaces in various superstores. Sometimes the product that was there in the shelf space, it is going out of stock, which means it's no more available. Now what is the next best product that need to be replaced over there in that empty space? How that decision is being taken. So it's currently, if you just think about, it's being taken by the store manager. The store manager thinks, okay, now this product is not available. You can put anything, right? So either you can choose anything random and put it there. Second option, maybe the past experiences of the store manager to pick any random items to put there, right? So the decision is being taken mostly like on the spot itself, and there is no data backed decision. Now, does this have an impact on the overall business? Of course, yes. If that empty space is a prime space in your central, or it's having a central position in your store, obviously people will see that this is empty, right? So to catch people's eyes, you need to place proper or right product there. Now, can an algorithm solve this problem? Yes, of course, an algorithm can solve this problem. How? You have to think about what is the next best alternate. So the algorithmic problem here is, can I identify the next best product that need to be replaced in the store space? So these are certain business problems and few examples. There are numerous such examples we can identify from various domains, be it insurance, banking, financial services, healthcare, retail, and manufacturing. So any domain, or maybe for that matter, maybe clinical trials, or any domain, you will find certain business problems. The other question is how this business problem is getting solved now. Is it solved through data? Is it solved through past experiences? Now, how can we streamline this process? Now, can the data which we have at hand be used? Can we apply any kind of hypothesis? Can we apply any kind of statistical procedures in order to get an answer for that? So for that matter, we need to frame right questions or right hypothesis. So the right question or right hypothesis is about, again, relating back to our first slide. Do we know how to ask the right question? Yes. Now frame a hypothesis out of it, and then pursue the statistical or mathematical modeling to get answers from that. So that's why the data science is nothing but it's a interdisciplinary study where all the methods, all the processes that we have seen could be used. Mathematics, yes. What level of mathematics? Definitely the mathematics up to high school grade is definitely useful, but beyond that, any kind of a higher order mathematics is also helpful in some specific use cases. Pattern recognition, yes, it is definitely important, because when you have been given a data set, First thing is that you have to look at what is the pattern existing in the data. Now, if that pattern can be associated with a statistical pattern matching, if that process can be used, or if that pattern can be used to fit an algorithm there. So let's take there is a cyclical pattern in a sales of a particular product. Maybe every year there is a particular season, it goes up and then goes down. There is a cyclical process. Now, cyclical is a pattern. Circular can be a pattern. Trend can be a pattern. Increasing trend, decreasing trend, different kinds of trends. So the patterns are nothing but patterns are the processes, or you can say the way the business runs. Now, if this pattern is associated with some of the data mining techniques, I can use those data mining techniques and fit this particular data and make a prediction for the future. So, the data mining techniques, like you start with data pre-processing, clean up the data, then do a proper restructuring of the data. For example, representations. Data need to be represented in the right form. So some kind of a visualizations, graphs or charts, etc., and then show the correlations or associations. So once you show the correlations and associations between various columns that you have in your data, you will find out that certain things are very much correlated, certain things are not correlated at all. Things that are correlated, can the causal relationship be established there? If there is a causal relationship between the data points that you have, you are finding correlations. Again, that can be used to make predictions. So, inference generation from the pattern recognition techniques or pattern recognition methods is also very much important. Similarly, mathematical models and statistical models. So, mathematical models, higher order mathematical models are basically nothing but you can say support vector machine. So, it's purely a mathematical model. So, what are the support vectors? The support vectors are nothing but the hyperplanes, which is being defined by your bunch of equations. Similarly, statistics is about, you can say, linear regression or logistic regression. So these are some of the statistical techniques that could be used. Now, these techniques, mathematical or statistical, these are basically nothing but just fitting those techniques to a pattern. Now, pattern recognition is very, very important. So pattern recognition, where it will come from your data mining techniques. So you are using data mining techniques to understand the associations between data points, finding out the causality with the help of a domain expert, right? And the data mining technique also involves your exploratory data analysis, which involves your univariate, bivariate, and multivariate. Univariate means one variable at a time. Bivariate means looking at two variables at a time. And multivariate means looking at more than two variables at a time. What does that mean? The univariate is about understanding the spread or the distributions. The distributions and the spread would help you in identifying the pattern, whether it is having an increasing trend, whether it is having a long tail on the right hand side of the distribution, which means it has a very skewed data. So, what kind of a patterns we can see in the data? Now, if we see similar patterns, we can make a prediction in the future. So, univariate is about analyzing the outliers, analyzing the exceptional cases, and looking at the distributions, whether it is symmetric or not. So, this kind of analysis will be doing. Bivariate is about looking at two columns at a time. So the data can be of two types. It can be of a numeric, it can be of string. Now, if it's a string and it's a category, there are finite set of categories. So you can do bivariate analysis by looking at one numeric and one categorical column. And you can look at two numeric columns and two categorical columns. So there are three ways of doing bivariate analysis. Now, multivariate analysis is about looking at more than two columns together to see any kind of patterns exist in the data itself, right? So once we identify the patterns, then we can fit a statistical technique. So it's all about connecting various fields together to solve a particular use case for the industry. Now, whether you create a product or whether you create or you are working on a project, right? How do we make the data science work, right? So to build better products or to make better decisions, to automate certain time consuming processes, we need the help of data science. Now, the intermediate or interdisciplinary topics or subtopics that we spoke about recently, like data mining, machine learning, exploratory data analysis, statistics, mathematics, These topics help us in creating a process, in creating a plan. Now, what are those plans? Those plans can be this way. So, first, you get a business problem and think about why it is a business problem, right? So, like for example, think about healthcare. Now, healthcare, what is a business problem? Okay, business problem could be, can I identify diabetic retinopathy? What is diabetic retinopathy? So, diabetic retinopathy is a disease which is generated if a person is having diabetic for a prolonged period of time. There is a chance that the person may develop diabetic retinopathy, because of which there can be a permanent loss of like permanent loss of eyesight, right? So if that's a problem, how data science can solve this problem, or how we can solve this particular issue. So the question here is, if I can identify beforehand that this is first grade of diabetic retinopathy, I can make arrangements there. What does that mean? I can make lifestyle changes, lifestyle modifications, having proper medicine, proper exercise, breaks, etc. So I can change my lifestyle and I can control that. Now, if I do not diagnose it in time, or do not detect it early, then it's very difficult to reverse a particular disease progression. So, what's the problem here? Identification of diabetic retinopathy. Now, the next question is, can I associate it with a mathematical or statistical problem? Yes. How? I have to collect data. I have to collect pathological data. I have to collect maybe some eye samples, maybe retina scan samples, and maybe some kind of a family history data. So these are the three factors which could impact the possibility of having diabetes or not. Now, if I have to make a prediction here, given those factors, whether the person is diabetic or not, I have to create a mathematical or a statistical problem. So here I can take, let's take as a simple example of, I can use a logistic regression model to make a prediction whether the person is diabetic or not diabetic, right? So I can associate this to a classification problem, the standard classification problem. Then obviously I will be looking for a solution. So solution here is, we have to predict in advance whether this person is going to be diabetic or not, right? Now, if we know that, and if we can predict it rightly, translate it to a business solution. So how do you translate it to a business solution? Okay, I can create an Android application or an iOS application where it will ask to upload or to just look at the camera and take a retina scan. And also it will ask for family history. It will ask for lifestyle, which means sedentary lifestyle or active lifestyle, or are you doing more of jogging, exercise, running, etc. So all those activities it will take, and it will generate a prediction, right? So people can self-diagnose themselves by looking at the mobile application or Android application. So which means people have access to now the devices and they can make predictions. Now here we can introduce a feedback system, whether this is working or not working. Too many false predictions, okay, the system is not working, and all the predictions are correct, okay, it's working. Now if all the predictions are not working, now how do we optimize this? Either our data is not right, or the model is not working, or there is something wrong. So let's investigate that. So that's why feedback and optimizing solutions are important for any kind of data science based solutions. That's why, how do we identify? Now, here the example that I have given about diabetic retinopathy, now it can be extended to any domain as well. How do we identify a business opportunity, or how do we identify an opportunity where data science can be introduced? So, how do we do that? Now, to do that, map the business process is the first thing. Then only you can identify the problem. So be it like some, you are working on some functions in a particular company, or you are being part of, there is a process always. So business follows a process, right? Simply, if I just talk about even university also, it follows a process. There is an admission process, there is a readmission process, there is a like, so everything is a process. Now, in a process itself, there are certain steps. You do this step, then you go to next step, then you go to next step, like this, so on and so forth. Now, while these steps are being taken, there are certain steps where you have to take a decision, right? The decision points are either yes or no. Now, for example, admission process itself, if the person is having grade A plus or no, right? So similarly, so there are certain processes. The processes will have the decision points. Now you have to think about how the decision points are being conducted. Is it data driven? Is it human driven? Is it something else? So how do we make a note? So typically we should make a note of like how the things are progressing. Now, if a human being is involved in the making decisions, then there can be possibly something go wrong, right? And if it's being taken by the machine, we need to keep a track of it. We cannot have full trust on the machines as well. So we need to put checks and balances there as well, right? That's why it's important to understand how the decision is being taken currently. Now, do we have to introduce a machine learning model or a statistical model over there, which is part of your data science intervention? Now, if I have to, or if I need a data science model to take a decision, the next step would be, do I have enough data to build a model? Now, if I don't have enough data, then it's a problem. Okay. Now, let's look at how the decisioning was being taken earlier and how it is being taken today. So, to model any kind of data to produce some output, we have a model and we will feed the input data and will produce the output. This is what was happening long back, which means you have y equal to mx plus c, which is predefined, right? Y equal to mx plus c, that is the equation which is already decided. It's a linear regression equation, and you feed the input data and you get the output. And m is defined, the parameter m has a value, x has a value which comes from your input data, c has also value. So y equal to mx plus c, which is fixed. There is nothing changing. Now, what's the changing in a data science world today is that the machine learning models. Now, here the value of m keeps on changing as your input data changes. Here, the value of a C also keeps on changing, depends on your input data itself, which means the values of M and C in the equation itself, it keeps on changing with the incoming data dynamically to produce the output. That's one. Number two is that MX plus C, or it is MX into C, right? MX multiplied by C or MX plus C, what kind of relation it is? Or it is M square X plus C, that we don't know. So the advantage of having machine learning models as part of your data science process is that you don't have to stick to a fixed model or a fixed equation to solve a prediction problem to generate the expected output. So what we have today is that we have the input data and output data. You send the machine learning algo there to learn that particular function. So learning that function means whether it is having a linear relationship, polynomial relationship, or any kind of a non-linear relationship, those things can be extracted. Now, once the model is extracted, the function is extracted, the values of parameters are extracted, then it is easy to make a prediction. That's why things are changing today because of the machine learning, the power of a machine learning models. We have better computers to make the training process faster, and that's why. So, what is machine learning then? The machine learning is nothing but it's just a program or just a computer program which learns with respect to a particular task from new data. So E stands for experience, T stands for task, and P stands for performance. Performance is a measurement criteria whether the algorithm is working or not working. Task is what is expected out of it. Are we expecting some to generate some kind of predictions? Are we expecting the algorithm to generate some kind of classifications or recommendations or groupings? So what is that task we are expecting the machine to perform? E is experience, which means the past experiences we can feed as data to the task itself to get trained. Now, if my machine learning algorithm performs better and better by receiving new data corresponding to or with respect to a particular task, then that's a perfect machine learning system, right? So, how to identify the task itself, whether it is a supervised problem, unsupervised problem. So the machine learning algorithms can be of different types. Supervised means you have input and you have output. You do not know the function. You need the algorithm there, right? So supervised means if I do this, I'll get this. If I do this, then I'll get this, which means there is a causal relationship between input and output. Okay. Unsupervised means you have only input data. You don't have a corresponding output data. Nobody has labeled the data, right? It's about finding out the natural grouping of various, you can say, data points. Natural grouping means so the data points are aligned automatically together to form a cluster, to form a particular group. That's basically unsupervised, where data is quite unlabeled and you need to apply certain heuristics or certain mathematical procedures or statistical functions there to group the data points together. Semi-supervised is one area where some of the data points are being labeled for which you will have output. There are some data points for which you will not have any output. And this is basically like half labeled, half not labeled. Reinforcement is a very, theoretically, it's a very old phenomenon. But practically, if we just see, there are processes, libraries today, which you can use to create reinforcement learning in practice. But theoretically, it was there long back. It's not a new concept. However, to practically make it work, the libraries are available today. So, what is reinforcement learning? It's about defining a policy to take an action. And if you are so there is an agent and there is an action. The agent is performing an action. Now, if that action is correct, a feedback need to be given to the process or the policy. The feedback can be, okay, this is a good decision, right? And if the prediction or the action that the agent is performing on a particular action is not right, then a penalty has to be given to the policy that this is a wrong prediction, right? So this penalty and the reward mechanism enforces better policy outcomes in the future. Now, if we train it couple of rounds, it will produce better results. So that's the part of reinforcement learning where the feedback mechanism is incorporated heavily in the form of reward and penalty to always do course corrections, to always do better in terms of making decisions. Okay, so that's the strategy towards how to identify the task. Now, what are the algorithmic interventions or developments that has been happening or happened till now? So earlier, statistical learning, which means using statistical algorithms like linear regression, logistic regression, binomial regression, negative binomial distribution, regression, etc. So many techniques that we are statistical techniques we are using to make predictions, classifications, etc. Now, during 2017-18, the machine learning concept came into picture, where machine learning is about writing your maybe Python pipelines or R codes to generate or automatically train the parameters, automatically train the functions from the input data as you receive more and more data. Now, machine learning becomes like it is like stereotype. Why? Because you need to have a constant function over there. Now, what is missing from machine learning models is that the feature interactions, the finite set of feature interactions, which means handcrafted features need to be placed in your training data set. The feature interaction, whether it is additive interaction, multiplicative interaction, what kind of interaction the features are having, you need to define that and you have to place a separate feature in the data set itself, which is practically possible if your number of features are less, which means less than 10 or 15. However, if your number of features are more, it is very difficult to do this handcrafted feature creation. It takes a lot of time. So to avoid this cumbersome process, and sometimes you may make wrong features out of it also. So to make this cumbersome process easier, then the artificial neural network came into picture where you don't have to worry about crafting separate features to take care of a non-linearity or something. What is important here is that you can simply use the input data and output data, do a back propagation, and the weights will get updated through various epochs or iterations. And finally, the model converges and you will get right weights from an artificial neural network, where the input and output data would have various hidden layers, and each hidden layer would have certain neurons. Neurons are nothing but the weights, and these weights get refined as you feed, as you do a back propagation and feed forward, right? So that's why this is called artificial neural network. And here the power goes to the algorithm to define the linearity, non-linearity, whatever it is. We don't have to define it. Now, next topic came into picture, the deep learning, where deep learning is about neural network. You'll have few layers of hidden layers. In deep learning, they are really deep because you can define n number of hidden layers. You can define n number of convolution layers. And so deep learning is typically suitable for image processing and audio processing, speech processing, speech synthesis, and also it is useful for image classification, image segmentation, or object recognition and natural language processing, because deep learning would be required for high dimensional data. The data dimensions would be very, very high in case of images, audio, video, and text itself. So after deep learning, then comes the reinforcement learning. So we call it a deep reinforcement learning. Here, the again the mechanism is reward and penalty to the policy, and policy becomes refined further more and more to generate better predictions in the future. Now, what is ahead of us right now is capsule network, which is a recent concept, and Professor Geoffrey Hinton has it's the contribution of capsule network is from Professor Geoffrey Hinton, and it's not in production, so we can expect a library anytime soon to generate predictions using capsule network as well. So that's the state of the algorithmic interventions so far. Now, whenever you are in a data science project or data science working on a data science pipeline, it's important to look at how we are taking decisions based on the samples of data and how we are choosing the right algorithms. So scientific Scikit-learn, which stands for like scientific kit for learning machine or creating machine learning algorithms. This is a Python-based library. That library can be used to generate or to create some bunch of code to perform various tasks. Those tasks can be classification, it can be clustering, it can be regression, it can be performing dimensionality reduction, etc., etc. Right now, the decision to do that is important. Now, that's being so. This is taken from Scikit-learn library itself. So here you can see if your data points are more than 50, you can possibly go ahead with doing some kind of analysis. If you have less than 50 data points, there is no point in performing data analysis. So you go back and collect more data, and data is something, right, which you need. Without data you can't perform any kind of analysis. Now, the types of analytics you are going to perform are four in nature: descriptive, which describes the as is scenario, what data is telling you and what's the information and how they are correlated or associated. This is more of like as is scenario, explaining as is scenario, right? The second important thing is about diagnostic analysis. So diagnostic is about reason finding, finding the causalities, finding the associations. So reason finding is important because this comes from your descriptive analytics itself. Now, once you identify the regions through your diagnostic analysis, you will be able to find out the X and Y. Y is effect, X is cause or causes. So once you identify X and Y, you can go ahead with predictive analytics. Here you can use X to make a prediction on Y, right? So the diagnostic analysis would help you in arriving at a problem for the predictive analytics. If your diagnostic says only there is X, there is no Y, then you cannot do predictive analytics. But if your diagnostic says that there is X and there is Y, you can easily perform predictive analytics and you can make a prediction what is likely to happen in the future. So if I can predict the future, then I can think about prescriptive analytics as well, right? So as an example, let's take you are expecting there is a holiday season which is coming up in next 1 month or 2 months, and during the holiday season you are expecting many people to come to your store. So let's take you have a superstore and you are expecting many customers to visit the store. Now, to support the customers in billing, in sequencing, in finding out the products, etc., you have support staff in your superstore. Now, what will happen if you are expecting many people to come and if you have less staff there to handle? That's a problem. So, if your predictive analytics tells you that okay, you will be getting more than 30% of customers from your regular customer footfall, which is significant enough for your store. Now, here prescriptive analytics would be, I'll be either doing contract hiring, I will be canceling certain leaves of people, so I'll make my manpower available to handle this kind of a volume. So, prescriptive analytics is part of again data science, just to ensure that whatever decisions we are taking and whatever analysis or whatever outcome the prediction layer gives us, and we are using it, and at least we are preparing ourselves. Okay. Now, the standard process of creating modeling techniques or standard process of creating models starts with the data. Again, the raw data is raw. It can be structured, it can be unstructured as well. Now, once we get the data, the next point is doing transformations and pre-processing. You clean up the data, you remove the missing values, you remove some junk values like maybe hyphen or comma or full stop or some kind of junk special characters like a hash, etc. So you should remove it from the data itself, because that has no value for analysis. That would anyways not help you in making certain predictions. So transformation would be required on categorical columns, because you cannot do a matrix multiplication on the non-numeric data. Hence, all kinds of categorical data need to be transformed and represented in a tabular form. Now, once you do this kind of cleanup and data transformations, next process is to have the input data for model building. Now, once you have the data for model building, you have to choose the algorithm. So again, you can follow the scikit-learn process of identifying what is the right algorithm to be followed. Now, once you identify the right family of algorithm and you train it. So once the training is done, validation step itself, just to make sure that if your model is generating right predictions. If it is generating right predictions, definitely you go for deployment. And if the predictions are not successful, it is not useful, your validation step itself tells you that your predictions are going haywire, it's not right, then you have to refine it. The refinement can be by taking more additional data, it can be adding more features, it can be choosing a different family of models, right? So this refinement process itself, it will remove the biasness from the data, it will remove the noise from the data itself to make the prediction better. Now, this process will continue till the time you are able to get a better result and your validation layer is successful enough. If your validation is successful, then it is good. If your validation is not successful, then of course you have to refine it till the time you get good results. Now, coming back to the tools to perform data science. So the tools to perform data science can be, there are different tools and you can expand the horizons. So the data science domain, mostly it is statistics and mathematical heavy, but also you need to, as a data scientist, you need to know how to extract the right data sets from tabular data itself. So first you need to extract the data. Once you extract the data, you can do processing, analysis, etc. Sometimes data extraction, you have to depend on a database guy. But as a data scientist, if you learn how to extract the data from the data servers or SQL servers or databases, it is easier. You are becoming more independent. You don't have to depend on the database guy to give data to you. So it starts with the SQL queries. So you should be able to write SQL queries and you should be able to extract the right data, right? Now, once you get the data, then you have a choice what kind of tools to be used. So there are various tools to perform analysis. SAS is the old statistical analysis software, pretty good, and it is a proprietary or enterprise based tool. Open source tools are Python and R. Okay. Now, in this scenario, what tool to choose when? If your organization has already gotten a license on SAS, then you should be using SAS software to do some kind of analysis. So the data that you are extracting from SQL Server can be fed to the SAS software and you can do any kind of analysis, and that's all. So you can go ahead with the SAS process. But if you don't have a license or enterprise-based option here, now you have to go open source. Now in the open source world, there are two ways. If You are developing a product which need to be integrated to Android application or any kind of iOS application or a web-based application. There is some application or solution you are developing, then you should go for Python. Why? Because Python is compatible with all kinds of technical stack, so that you can create RESTful API services and microservices which can be easily integrated to various software platforms. So Python is pretty much easier for integration purpose, and also you can create microservices. And definitely Python is very flexible also. You can write the algorithms and data processing layers in Python as well. That's why. Now, if you're working on a project where the objective is to get insights and create some presentations out of it, or maybe create a dashboard out of it, link it to the some of the existing dashboards. So it's important to use R as a statistical computing tool. So R and R Studio. So R is the statistical software, and R Studio is a front end to it. R Studio is just about like a console. You can do drag and drop, and you can do various things, of course, over there. Now, for analysis, if you have unstructured data, and again, unstructured data, you will have libraries and all three tools, SAS or R or Python. All three tools would have the unstructured data module as well. Using this unstructured data module, you can create features, you can train models, and you can make predictions, etc. and etc. However, the data volume, if it increases, if the data volume is in like in GBs, right? The open source tools, obviously SAS can handle it. So how? Because SAS is hosted on a server, and of course, the if you want to write distributed computing, you can do that there. However, for the open source tools like Python and R, if you are uploading a GBs of data to a computer, the computer may crash or it may slow down, and it will not you will not be able to proceed further. The problem here is these are all in-memory tools. Python and R both are in-memory tools, and they perform in-memory computations. When you upload a heavy data set to the computer using Python or R, it basically blocks the memory. So it is subject to how much memory is available on your machine to process it. That's why to power the processing power or to increase the processing speed, you will be using Spark for that. So Spark is a distributed computing framework or distributed computing library, and it's also open source. You can use R and Spark. You can use R and Python and Spark also. If you're using Python and Spark, the library is called PySpark. If you're using Spark and R, it is called a Spark R. So both the platforms are compatible with the Spark, and you can use or leverage the distributed computing power of a Spark to fasten the pipelines that you have written in R and Python as well. Right. So as a data scientist, now you have to learn these many tools to perform various kinds of analysis. So I think we have uh, this much information for now. Now the forum is open for Q&A. You can ask any questions if you have any.
Hi, thank you, Mr. Pradeepta, for the great sharing. It was very insightful, especially for a student whom are getting to know data science newly. So now let's move on to our Q&A session. I can see questions in already, so
Sure.
I'll start with the first question. Is it always advisable to implement deep learning models?
No, it is not always advisable to use deep learning models. Why? Sometimes simpler models may work, right? For example, if you are making a simple linear prediction, linear model is giving you 95% accuracy, there is no need to go for deep learning. It's not required at all. But if the model is not scaling and the model is not producing valid results, for example, you are using a linear regression model, it's giving you accuracy of 46% or 47%. Why to use the model? It's of no use, right? So sometimes the simpler models, the machine learning models, statistical models, if these models are not working, they're not giving expected results, then you should explore deep learning. That's why it's not always by default we should go for deep learning.
Right. Thank you, Mr. Pradeepta. So the next question is a transition possible to the data science field from a non-technical?
It is possible, but a lot of effort is required here. Even if you are from a non-technical background, I think you have to learn programming. because programming is the future. As you learn programming and you will put in effort there, learning new tools, learning new languages, be it Spark or R or Python or Java. If you are learning different techniques, it is possible. Not mandatory, but it is possible to get into data science. Now, within data science also there are different kinds of roles. Okay, so the roles are like there is a domain expert role, there is which is non-technical, writing
Okay.
insights from the statistical analysis or modeling results, writing insights or business recommendations, that is also non-technical. You don't need programming skill sets. Data validations, for example, making the prediction, testing basically the effectiveness of a particular model. It's a testing job. So you are just testing the functionalities, the predictions, the consistency, the stability, the accuracy, the reliability, all those things you are testing. Here it is also a non-technical role, which you don't need technical expertise. You just have to know as a business user, is it good or bad? So there are three different kinds of roles which are available. Now the fourth role is about data labeling, right?
Okay.
So data labeling, like for machine learning training, you have to label the data, right? And people from I think psychology department, people from English department, they are contributing in data labeling for machine learning. They are not from technical background, right?
Okay.
So yeah, so there are possibilities, but if you still want to learn, and you have to put a lot of effort in learning the programming.
Right. Okay, the next question, I think it's almost the same, but he asked that is it a must to learn data science if you are a software engineer?
Absolutely. So if you are a software engineer, I think, uh, see, if you are working for a particular company who are into product development,
Okay.
so AI data science is going to touch each and every domain, whichever domain it is. So when you are a software engineer, you must be working on some domain, basically
Okay.
building or developing a software product for a specific domain. Now here, sometimes you have to face, or sometimes you have to work in a team with a data scientist. Then you need to know what is data science, what he is
Right.
talking about, what model he is talking about, how do you integrate the models, how do you do deployments there. So these are certain challenges. So as a software engineer, you can add, I mean, if you are part of any data science team, then you need to know.
Right. Thank you, Mr. Pradeepta. So the next question is, what's the difference between data science, data analytics, and data engineering?
Very good question. Now, data science, as I said, it's more of like fitting the business problem to a mathematical or a statistical problem. So, first you get a business problem, convert the business problem to a math or stats problem. Now, use mathematics and statistics to get a result out of it, and then translate it to a business solution. So, that's about a data science role. Data analytics and data science, they are synonymously used. Data science is a very recent term. Data analytics is a very age-old term. Data science came in the year December 2012. Data analytics was there long back. Since last 50 years, analytics was there. So, so it's not a new term, and both are exactly the same thing. Data engineering is different. Now, what is data engineering? Here, data storage, data processing, data migrations, data flows. These are four different streams where data engineers are required. What does that
Okay.
mean? So, which means, like, let's take, you are collecting structured data, you are collecting unstructured data, you are collecting images, videos, etc. Where you will keep it, right? And for what purpose you are storing it? You are storing it to get some insight so that you can use it for future. If there is no insight you can extract, there is no point in storing it, right? So unnecessarily you are just occupying your hard drives with lots of data which is of no use to you. So
Okay.
the point here is where to store. Storage should be done in such a way that you should be able to access it. Storage should be done in such a way that you should be use it when the time whenever you need it. But if you are not able to use it, there is no point. So the role of a data engineer is that create certain pipelines to optimally store the data, to optimally process the data, right? So storage garbage, so storing data with garbage versus storing the data after pre-processing for further consumption. There is a huge difference between the two. So data engineer is about all the, I mean, you have to do everything with data, just about migrating, doing ETL, doing some joins of the tables to give it to someone for some purpose. Right? Think about an organization where the HR data, operations data, right? You have let's take finance data, vendors data, general attendance data. There are so many data tables, right? And all those data tables are scattered because the audience are quite different. Now, if your top level leadership they are doing some analysis, they would want data from all departments. So you have to connect all the department data together to give it to them. So your data engineering pipeline basically should be able to handle multiple data sources in discrete data sources where it is being stored, should be able to access it, should be able to process it, should be able to give it to the person within the organization as they need it.
Right. Thank you. Thank you. So the next question from David is that what are the data scientist job fields? She's asking
Yeah.
about
So
the fields. That's yeah.
right, right. So data science job opportunities are there everywhere. Everywhere.
Okay.
So I mean, whichever domain it is, it's there. And it starts with basically programming. So if you are a beginner, if you are straight out of the college, I think the quickest thing would be to crack it as a programmer, as a developer, right? So for that, what you need to know, you need to know a couple of libraries. So whether it is Python or it is R, you can decide which library to use, but be good at that. If you want to be good at Python, be good at Python and do a lot of programming and hands-on programming and just build a skill set like I'm a Python developer. So you enter the field as a Python developer. Gradually, you learn the domain expertise, you learn the statistical models, you learn the machine learning models. So gradually learn all those things and collect it. But to get started on this, you start with as a developer.
Right. So the next question is like, is it easy for us to learn data science?
Why not? It's quite easy.
Right.
It requires only 6 months of effort.
Okay. Right.
So
So
every day if you spend 2 hours only, beyond your work or beyond your college, and also if you can spare only 2 hours a day, only 2 hours, statistics you can easily cover within 30 days, easily
right.
covered.
I hope.
Next 60 days, next 2 months, you can easily cover the programming side of things. Again, 2 hours, not more than 2 hours a day. Python programming you can easily cover in 60 days, which means 120 hours is good enough to get started on Python programming, right? So it's
Right.
pretty easy, and it only requires conscious effort. And also, what is important is the mentor's role is very important because today what is happening is that if you want to just give a search how to learn data science, you are getting millions of search results. So you really don't know where to start. So that's why the role of a mentor is very important. Curated contents or materials also very important. Python, okay, learn Python. You'll get thousand things learning Python online, which is pretty difficult. You don't know where to start. So the point here is you need to be given a particular book. Okay, you follow this book, complete it within 30 days. You will be good at Python, right? I mean, there are thousands of books, but yes, what is that one book that I should read? Just my starting. Next, I can read other books and just increase my knowledge. That is fair enough. But to start with, what is that one book I should read? So, this kind of focused approach. So, a mentor's role is very important in telling you that statistics, tell me one book, Python, tell me one book. These two books I will complete in these many days. There has to be a target. So, it's quite easy. And the power of open source is that you don't have to pay anything. Just you need to have a good internet connection and a good laptop. That's it. Just do
Right.
open source installation and get started.
Yeah, I think that's the question like every student will have, and thank you for answering that. So next question is from Melvin. What was the most difficult data science or AI problem you have faced in your career?
Oh, great. See, the most difficult problem I would say is that uh, we want to solve problems, but we don't have data. We have a business problem, but we don't have data. So if you don't have data, how do you handle the problem? The problem will remain problem, right? So I think data is, or see, some data, correct data, no data. There are three things. No data, you can't solve it. You have some garbage data, but still you can't use it. What you need is good data. It's just about like, I mean, we teach our kids, right? This is tiger, this is leopard, this is lion. So we teach the animals. If they don't recognize it properly, that means the learning is not perfect. There is something wrong in it, right? And we have to provide them data. Okay, a tiger, the shape should be stripes, not circles. A leopard, it should be okay, it should be circles. Lion, you'll not find any spot. It's all about one color. So you are telling data to the kids so that they learn it better, right? And we are telling them, so learning through data, learning through information, versus blindly remembering something and telling them that this is what it is. I don't know why, but this is what it is, right? So data is the most difficult thing. If you don't have data, you can't solve the problem. And you can get started on a theoretical aspect. You can collect some data, you can collect some sample data, survey data, etc. But that is of no use. You can't rely or build a solution out of the survey data.
Right. Thank you so much. So the next question is from William. What are the some of the common mistakes made by a data scientist?
Very good question. Now, this one is also, so there are 10 common mistakes people do. One, directly jump to the algorithm, right? That's not the right thing. First, you do like proper data analytics, which means look at the data and understand. And suppose you are doing some analysis in Excel. What happens? You put a formula, that formula goes wrong. What will happen? You will find a pattern like has n/a, and nobody removes that. You save it as it is. Now, once you upload it to any kind of open source tools, Python or R, that will become has n/a. Is this a valid field? Is this not? We don't look at it. So typically, we don't analyze much, and we jump into the model building. That's one. Second problem is that we directly jump from algorithm to algorithm. This one is working. Oh no, it's not working. I'll go to the next algorithm. I'll go to the next algorithm. Now this is a problem. Why it is a problem? So today you are saying I'll be using linear regression. Tomorrow you are saying I'll be using random forest. Day after you are saying I'll be using gradient boosting. And next day you are saying I'll be using neural network. Every day you are running from model to model in order to address a problem. However, you don't understand it's a data problem itself. It's not an algorithmic problem, right? Sometimes data problem need to be identified. So as an analyst or as a data scientist, you have to know exactly what problem, what algorithm. You can't just jump. And if you jump, there is a problem because you have to communicate to the client also. Today you are telling the client that I'm using linear regression. Tomorrow you are saying, oh, I'm using deep learning for this. What? So you can't use like this, right? So it's the second mistake. The third mistake is that think yourself as a user, or like as if you are the common user who will be consuming the predictions of a data science work, right? So no
Yeah.
mathematics. So don't talk about mathematics while explaining the insights to me. You talk about simple language, right? You cannot just say if this increases by this and this is increasing exponentially to the power of something, something. No, I can't understand that. So think yourself as an ordinary business user and explain the data science results. So no mathematics while explaining the results of a data science outcome. That is the third mistake people usually do. Fourth mistake is that data problems they don't understand. They directly think about it's an algorithmic problem. So
Right.
question the data. Always question the data. Is it the right data? Why it is so? Ask the person who has given the data to you why this is so. Is it correct? Is it right? So ask a lot of questions around the data. And also don't jump to the models first. Now that's another mistake. You get the data, sometimes a simple if then else rule also work. Simple things also work. There is no way to go to directly machine learning, deep learning, etc. There is no way. So a simple thing, simple solution. Keep it simple. Don't have to make it jazzy by using fancy names, fancy libraries. No need to use that.
I think these are like common mistakes as students, data analytics students would make also. I think
Yeah,
there'll be a answer for every student as well. And the next one is what's the importance of model tuning?
correct. Model tuning is like so sometimes what happens, uh, you train a model, the model is performing, but all of a sudden you will find the predictions are going haywire. Sometimes it is generating two big predictions, two small predictions, incorrect predictions. Like a lot of false positives are getting generated. And why this is happening? Is it because of the new incoming data? Is it because of something? That's why you have model metrics. Model metrics, how we are going to identify data drift, concept drift. These are the two techniques typically people use to identify whether the model is drifting away from the expected predictions, what it's supposed to do, if it is doing that or not, right? So model tuning means again fine tuning the parameters with new data. Now suppose
Right.
mx plus c, your m is like 0.25, and this is generating wrong predictions. When you tune it with the new data, this could be instead of 0.25, it should be 0.13 or 27 or something else. So model tuning will update your parameters in the model in order to correct the predictions. So model tuning is very much important.
Okay, thank you. And the next question is what software tools and techniques does the team use regularly?
Right. For data science work, it is today it is mostly Python, and it is free, open source, and you have a significantly large number of libraries that you can use for discrete tasks, and you can virtually do anything and everything using Python. So Python is the leading tool in data science, and you can create RESTful API services also that can be given to data engineering teams for integrations with the various applications. So that's why it is quite easy. So that's one. And from software point of view, I think various softwares are there today, which are basically low code, no code tools where you can just do drag and drop and to train machine learning models. And behind the scene, they are also using R and Python.
Right,
Right.
right.
So there are softwares like SAS is there, then SPSS is there, Minitab, eViews, Data. So there are so many statistical softwares available today. But the problem is some of the softwares they cannot handle huge amounts of data. Some of the softwares they do not have all the existing list of libraries. Some libraries you will find in some tools, but it is missing in others. Specific techniques you will not find options in the drop downs in the software, so there is a limitation. That's why if you are using open source tools like Python programming and R programming, you can do anything. You can write your own code basically, so you don't need a drop down there. That's why it's quite easy, so you should follow Python only.
All right. So following up with the next question, what requirements does employers looking for to employ a data analyst or data scientist nowadays?
Correct. So first thing, I think if you have prior experience in any data science or as a data analyst, so definitely what exactly you did in your previous work, what kind of analytics models you have trained, what is your learning from there? That is one important thing. Now, if you're a fresher and you don't have any prior experience, now here the basic things would be the conceptual, like concepts around matrix multiplication, concepts around eigenvalues extraction, understanding what are eigenvalues, how the determinants work or how the matrices gets multiplied, what is the inverse of matrix. So the concepts like what is back propagation? Can you explain what is back propagation? So those kind of conceptual questions would be asked just to check whether you understand the concepts or not. That's one. Number two, programming skill set. So it is if you are a fresher, mostly it is going to be programming heavy, which means okay, how do you write a loop, or what is the difference between list comprehension versus for loop? What advantage you will see? What is the difference between multiprocessing and multi-threading? If you have to do like 1,000 Excel files, you have to process it and create a data frame, whether you will be doing multiprocessing or multi-threading. So and how to maybe delete a thread, how to merge a thread. So those kind of things. So programming related things, modularization related things. So it is going to be mostly programming heavy if you are a fresher. If you are experienced and you are already working somewhere, definitely what you are doing as a data analyst or data scientist there. That is one attribute. The second attribute is about articulation, which means you are producing some output. Now you have to convey that to someone or manager or a senior manager. You have to tell them that what it is, what is the story behind it, what data you used, how you used it, and what outcome it is giving, how this outcome would be helpful for me.
Right. I mean, that was a very useful answer for all the finalist students here, I guess. And the next thing is, what is the biggest challenge in data science?
Right. So the biggest challenge, I would say, as I said earlier, also data is one challenge. Now let's assume that you get the data, and let's assume that also you get the right data. Right. The next challenge is fitting the business problem to the data problem. That's the first challenge, right? So let's think about how many cars are running on the road today in Malaysia. That's a problem. I just need to know how many cars are there on the road today. That's a problem. Now, how do you approach it? Is it a data science problem? Is it not a data science problem? So how do I get that estimate? Any approximation, any number, because we don't
Um,
have data. That's fair enough.
yeah.
But without data, how can I reach the approximation there? Right approximation. Is there any way I can identify?
No, I guess.
Okay. Now, if I observe at least one traffic signal
Okay.
and I'll see in 1 minute how many vehicles pass a signal.
Okay.
Let's take 20. So let's take 20, right?
Okay.
And how many total signals are there? Just an
So,
example,
yeah.
just to reach the right approximation, because there is no right answer, wrong answer here.
Yeah.
It's about how you are approaching the problem,
Mhm.
right? So that's one. The similar kind of problems can be given, like open-ended problems would be given to you, right? How can
Yeah.
you reduce air? How can you improve the air quality? Can data science solve the air quality problem?
Mhm.
Can I predict like the optimum moisture level that can be given to the plants in a agri-tech business, right? So
Yeah.
the innovations are happening in three sectors today: edu-tech, health tech, agri-tech,
Okay.
agriculture technology, healthcare technology, and
Mhm.
education tech, right? These are the three things where data science or AI are being used today. Now, how it is
Mhm.
being used? So, in for example, in school education, to again augment the teachers, helping the teachers in improving students' quality of education, we can introduce data science there, right?
Mhm.
Similarly, we can introduce data science in agri-tech also, health tech also. So the challenge here is fitting the right problem to the right algorithm. That's the challenge. Once this is
Right.
solved, technology you can solve it.
Right. Understand. Thank you so much. And the next question is from Johnson. How can a data analyst help a business or a corporate?
Right. So, see, business and corporate, there are different kinds of decisions. So, let's take as an example, you are a businessman and you are in the hotel industry. Okay. Now, you are visiting Singapore, let's take. You want to make an investment in one of the hotels because you have some corpus. You want to make an investment in one of the hotel, one or one more than one hotel you want to invest. How do you identify which hotel to be invested? There are so many
Research
hotels,
about yeah.
right? So how do you identify which hotel I should make investment? What is that
Mm,
factor that helps you?
I think the potential
Obviously,
location or something.
yes, obviously financials, right?
Yeah.
Whichever
Mm,
hotel has a good revenue or good profit, I will be
yeah.
making that investment. But why would they share their bookkeeping and finance with you? That's the
That's
problem because there
yeah.
is no data, right? So how do you arrive at it?
So
Can any
that's when.
data analyst help there? Right. So for example, what you have to do is, okay, this is a hotel ABC. This is owned by Mr. A.
Okay.
Mr. A has three companies. One of them is listed in the stock exchange. So if it is a stock exchange, you will know the financials, which is public, right? So
Yeah.
basically connecting the dots and arriving at an estimate. Now the role of a data analyst would be finding out all the hotels, big hotels that you think are making more money. Now, who are the owners of these hotels? What are their corresponding other businesses? Is any of the businesses listed? If it is listed, then what are the revenues or what are the profits they make? You will find that what is the news is all about. Now, how much they're making? Is it in the news? Is it in the public domain? So that's the way to collect data and help this person that okay, where to make investment. Why do you think
Right.
that you should make investment there? Right? So that's all about search open source and publicly available information, collect information from everywhere and help the business or the corporate,
Right.
right? Same thing from like if a new company, let's take some XYZ company and they have a smartphone. They want to launch the smartphone in Malaysia first time. They would ask a question, okay, which city should I target first? So how do you tell which city to target first? Because it's a budget smartphone, it's a new phone. They want to launch it because you know the capital is already penetrated. There are
Yep.
too many smartphones there. So it's a budget phone. It's not even a high-end phone. If it's a high-end phone, definitely the capital city would be able to afford it. But if it's a budget phone, so which are the cities they have the highest potential so that they can only market those cities in, right? Now, if I know the GDP, GDP of the localities, cities, I know that what is the per capita income of people in different cities, different places. I can just figure out, okay, these cities you go and target because here the per capita income is this much and they could afford this budget phone.
Right.
So you could increase more. Now you are providing your consulting services to this new smartphone company, right?
Yep.
So that's how, as a data analyst, you should be able to help the business. Now, here comes the role of a data. How do you collect the data at a per capita level, right? So, is it available first? If not, then what is the approximation we can use? What is the other alternate data available to help arriving at this result, right?
Right.
Yeah, that's what.
Yeah. That was very well explained, sir. So next question is, why choose data science as a future?
Right. So definitely, see why choose data science as a future. I think everybody is doing data science in some form in today's personal life. I mean, as an individual also you are using data science. If you have a need to buy a new smartphone, what you are doing, you're going to Amazon or some other e-commerce portal and comparing multiple products and doing feature comparison, price comparisons, right?
Yeah.
And you are taking a better decision. Now that's data science, right? Because here you are not using any model to arrive at a decision, right? But again you are taking a decision. Same thing, any sector. So maybe you can think about the healthcare also. Today if you are going to the doctor and you are asking or you are visiting the doctor for some reason, and let's take the doctor is asking you what is the resting heart rate, and you are using Apple smartwatch or any Fitbits of the world and etc., right? You are giving the right estimate. You are giving, okay, your resting heart rate for last 90 days is this much. Now, this is giving correct information to the doctor. However, without or in the absence of this smartwatch, what is happening? The doctor is putting the pulse meter and taking a measurement of resting heart rate at that point itself to make a decision. At that point in itself, the person may be in stress. maybe thinking something else. That could give a wrong resting heart rate as well. So, wrong data collection could lead to wrong interpretations. Now,
Yep.
if I give a longer time cycle and better data, the doctor can make a better decision. So, why data science is a future? I think yes, because everywhere, wherever there is a decisioning, you need data. And if data is there, data is telling a story. That story should be coming out.
Answer. So I think there's one more question. Since data science is growing, would businesses face any negative impacts if data science is not implemented in their organization?
Definitely, yes, they will be losing competitive advantage. See, if you are performing data science, you know what is coming, you can predict the future, you can take smart business decisions.
Right.
If you are not implementing, see, the basic thing is going digital. If the businesses are going digital, and you have to make a prediction. If you are predicting, you are definitely using data science. If you are not digital, you are out of the business. So digital is the new world, right? So if a business doesn't have a online presence, nobody is thinking about them even. And is this a brand even exists? They don't know. People don't know, right? So what is there while surfing? What is there? What is coming in front of you? And that's the business you know. So awareness. It's all about awareness. So to become to make the people aware about your brand, it is important to go digital. If you go digital, then you have to make predictions. For that you need data, and for that you need data science.
Understand. Right. Is there any more questions? Okay, I don't think so. There will be any more questions. So I see good. So with that, we have come to the end of our webinar today. Once again, thank you, Mr. Pradeepta, for giving your valuable time and sharing your expertise. We really appreciate your professionalism and dedication in answering all the questions raised. So keep doing such a great job in community, and we are looking forward to meet you again in some other good times.
Thank you.
Thank you so much. And
Thank
to
you.
the audience out there, thank you so much for participating today. We really hope this session was beneficial to everyone in terms of learning about data science. And your certificates will be emailed soon as well. So if there's any questions or concern, you can always reach out to us via the email address provided. We'll be having our next session with practical hands-on as a continuation of this webinar soon. Please do join that as well and keep learning. With that, that's the end of for today. Have a great day and weekend ahead. Take care and stay safe, everyone.
Thank you.
Thank you, sir. Thank you so much.
Thank you.